Welcome to a new episode from the series Automotive, Benefits Beyond the Bond, where we explore the latest solutions in adhesive technology for automotive instrument panels. In today's episode, we will hear from the industry's leading experts about the challenges, latest research, developments, solutions, and sustainability initiatives related to this topic. Buckle up and enjoy the ride. Please welcome Mark, Sika's product manager for interior adhesives, who discusses the crucial role of adhesive technology in the development of automotive instrument panels.
Due to the eye panel's central position in the vehicle interior, it is in the direct field of vision of the driver and passengers and is also placed directly behind the windshield. This makes the instrument panel particularly important for the aesthetics of the entire interior, as well as for its resistance to extreme temperatures caused by effects of sunlight. Currently, the trend in the automotive industry is to primarily use laminated materials for the instrument panel. This means that the decor is bonded to the carrier. Due to its size and complexity, the instrument panel may consist of several parts. This is important because the requirements for bonding an instrument panel differ depending on the installation height in the vehicle. As the elevation on an instrument panel increases, the requirements, particularly for temperature resistance, also become more stringent. The upper part of an instrument panel requires a temperature resistance up to 120 degrees, while low-lying components are sometimes validated at just 90 degrees. Additionally, legal regulations in the workplace and the latest regulations on the recycling of cars, which also affect the vehicle interior, impose further requirements on the bonding and materials used in an instrument panel. Of course, the fundamental challenge in the automotive industry of producing as cost-effective as possible remains. In order to meet these challenges, automobile manufacturers have created catalogs of requirements that contain testing regulations. There are an extensive number of tests which can also vary across manufacturers that must be fulfilled. As already mentioned, a temperature resistance of 120 degrees is required for the upper part of an eye panel. Many adhesive technologies cannot withstand the high temperature requirements. For this reason, manufacturers often use temperature-resistant reactive polyurethane hot melts to cover the carrier material with a decorative film. However, RPU hot melts also have some crucial disadvantages. On the one hand, they limit the choice of carrier materials. Popular plastics such as polypropylene require complex pretreatment, which manufacturers would like to avoid. On the other hand, when used, many of these RPU hot melts release isocyanates into the environment, which are considered potentially carcinogenic and can trigger allergies. Automobile manufacturers are therefore striving to minimize the use of isocyanates in order to protect both their employees and the environment.
Next, we visit Claudia in R&D to learn about the efforts made to meet the automotive industry's demand for reduced or isocyanate-free adhesive solutions, along with the benefits in terms of cost and sustainability.
We thought about how we can reduce the residual monomer content of our PO hot melt range. The current content is between 2 to 3%. In the first step, we developed the PO hot melt range with the content lower than 1%. Here it was not necessary to introduce new raw materials, but we changed the manufacturing process. This product range is already placed in the market for a long time. The next step, we want to develop the PO hot melt range with the content lower than 0.1%. Here definitely we have introduced new raw materials, but we can stay with the current manufacturing process. We can offer reactive adhesive system without using isocyanate. The reactive polyolefin hot melt based on a different chemistry. The reaction is accomplished by hydrolyzing the silane group by water. This product group is label-free. I see the possibilities that the reactive polyolefin hot melt can replace a PO hot melt, but not in each application. Every adhesive system from us had its advantages, but also their limitations. A limitation of the polyolefin hot melt is the heat resistance, where we are not reached yet the level of a PO hot melt. But with the reactive polyolefin hot melt, definitely we can close the gap more and more. One other limitation is the low adhesion to polar substrates. A big advantage of the polyolefin hot melts is the excellent adhesion to non-polar surfaces such as polypropylene. If you have a look on recycling and consists the component of PP, substrate, TPO carrier and a polypropylene hot mat, this can be recycled more easily due to the same chemical basis. The other point is that polypropylene is a cost-effective material.
Frimo Innovative Technologies is a global leader in plastics processing equipment for automotive interiors, with production facilities around the world. With an extensive technology portfolio, including PUR foaming, flexible trimming and punching, various welding methods, compression molding with back injection and advanced laminating techniques, Frimo continues to drive innovation in the industry. As an early adopter of Sika Melt 890 in serial production, Frimo has first-hand experience with its benefits. Today, we're joined by Christian Gill, Director of Business Development at Frimo, to share insights on this technology and its impact.
Instrument panel manufacturing has shifted with larger displays and lower noise dampening needs in battery electric vehicles, enabling advanced laminating technologies like press, vacuum and IMG laminating. Sika Melt 890 revolutionizes the market with direct PP bonding without pretreatment and excellent adhesion. It passes climate tests for dashboard and eliminates the need for flame treatment. Today, many car models use Sika Melt 890 for TPO to PP bonding, a sustainable, recyclable solution. Processing Sika Melt 890 requires advanced tooling and equipment. Its high activation temperature demands precise heating. Its exceptional adhesion properties extend to tooling, specialized masking and coating technologies. The benefits outweigh the efforts. IMG and vacuum laminating enable highly automated production. Previously, slushed and foamed dashboard took minutes to process with manual steps. Now, our equipment achieves 25-second cycle times per panel with one operator, while Sika Melt 890 cures automatically. Sika Melt 890 remains essential for instrument panels, enabling automation and sustainability. Partial glue application reduces waste, while ultrasonic airbag weakening ensures safety without fumes. Its use expands to decorative materials like fabrics, with press laminating lines already in operation. Sika Melt 890 also proves versatile in door panels, now in serious production.
Sustainability is crucial for customer solutions and competitiveness. Vera Fischer, Sika's Sustainability and ESG Specialist, will discuss the focus areas for Sika's purchasing and procurement teams.
Sika's procurement teams prioritize sustainability in all its forms, directly contributing to reducing the environmental footprint across Sika's value chain, enhancing social responsibility and ensuring compliance with regulations. For interior bonding applications, like instrument panel bonding, with Sika Melt we offer a new solution that overcomes the current challenges. It combines new labor-free raw materials into a product that even performs on low surface energy substrates like polypropylene. The answer lies in selecting and collaborating with our suppliers, who play a crucial role in helping Sika achieve its environmental targets and meet supply chain due diligence requirements. That is why we have embedded responsible sourcing elements in our new procurement strategy 2028. In 2023, purchased goods and services contributed to more than half of Sika's total emissions. To make a significant impact on reducing these emissions, we must decarbonize our supply chain, with our suppliers playing a crucial part in terms of emission transparency and emission reduction. By providing supplier-specific data of the raw materials we buy, they improve the reliability of our emissions calculations. Furthermore, we want to enable innovative developments, which ultimately our customers profit from. Moving on to our social and governance considerations, in the last couple of years we have seen a shift in the regulatory landscape concerning supply chain due diligence requirements. It was a key driver, along with many others, in formalizing Sika's due diligence approach, covering risk identification, risk assessment, and contributing overall to improvements in the value chain. With that, we are also mitigating any risk of non-compliance and global standards. It is our mission to ensure that all our suppliers are selected and regularly evaluated on their commitments and standards towards environmental, social, and corporate governance. For that, we collaborate in chemical industry associations like the Together for Sustainability initiative.
Thank you for exploring with us Sika's innovation in automotive instrument panel adhesives as we work towards a more sustainable future. We hope you enjoyed this journey. Please join us for the next episode where we uncover more exciting advancements in the automotive industry.